I'm Captain Anderson, as you know by now, and we're up to episode 3, the carbon ratio. There are two types of carbon ratios to be concerned about. First is the ratio of carbon taken out of the atmosphere versus the amount of carbon replaced. That ratio has to be 1. If it's not 1, then the Earth is either going to heat up or it's going to cool off. But carbon is a very volatile atom, very powerful atom when it comes to attracting heat and radiating it back to the Earth. That's what's heating us up, and that's the problem. So we need to know we need to keep that ratio of 1, and I will show you where the ratio is today. 2, the percentage of carbon removed from the atmosphere naturally compared to the total amount of carbon replaced by human activity. That will tell you how hot we are based on what the carbon ratio is. Here's the first type. This makes it easier for me to understand. This helped me to visualize what was going on. If you look to the circle on the far left, you see there's too much carbon in the atmosphere, and the Earth is obviously too hot for life. In the center, there's not enough carbon in the atmosphere, so the Earth is too cold for life. On the far right is where we are today. A great deal of carbon is stored in the Earth, where it's just sitting there docilely waiting for us to burn it. And yet there is some in the atmosphere, just enough to keep the Earth warm, blue, green, and very livable. That is the carbon ratio. I'll move my cursor over there. You see this CO2 being pulled out of the atmosphere of the Earth. This is not a static situation. It's constantly changing. Photosynthesis removes the CO2 from the atmosphere, and a very tiny portion of that gets buried in the Earth and turned into fossil fuels. That means the total amount of carbon in the carbon cycle has been reduced. Fossil fuels are not in the carbon cycle unless humans decide to take them out of the ground and burn them. Then the carbon goes back in the carbon cycle. So here the CO2 is coming out. Now for us to stay on Earth permanently, we have to put back into the atmosphere the same amount of carbon that nature took out. So let's see how close we are to doing that. Here's the second type of climate change. The percent of carbon removed from the atmosphere has been replaced by what percent of the carbon that nature took out of the atmosphere in the last 50 million years have the human activity put back. So that gives us the carbon ratio, and that looks like this. Carbon ratio equals total amount of CO2 put back in the atmosphere by humans divided by the total amount of CO2 in the atmosphere before the Earth began to cool. I mean, it's that simple. If we know how much was in the atmosphere before the Earth began to cool, and we know, because we can measure how much carbon was in the atmosphere before the industrial period, and we know how much carbon we've put back in the atmosphere since the industrial period, then we know exactly how hot the Earth is going to get. So, and in order to do that, of course, we have to understand that there's a linear relationship between the amount of carbon in the atmosphere and the Earth's ambient temperature. And in previous episodes of this presentation, I explained to you, while it's completely common sense to me that has to be, I still needed confirmation from some PhD. And eventually I got it. So the linear relationship is there. So if it took 285 parts per million to make the Earth 56 degrees pre-industrial, then what is it going to take now? What is it going to take when the Earth was 77? Scientists generally agree that 50 million years ago, the Earth was 77 degrees, far hotter than humans could stand. That's 77 ambient temperature. But so you do a little arithmetic, and what happens? There it is. You come up with 392 parts per million. Well, that seems perfectly logical, except it doesn't agree with anything the scientists are talking about. I looked everywhere to try to find out what they believe the number is. There was one scientist who said there was 4 times more carbon in the atmosphere before the Earth began to cool than there was in the pre-industrial period. In other words, he thought there was 1,140 ppm, parts per million, 50 million years ago. Well, that's a hell of a lot bigger than 400. And there was another scientist who said he thought it was 850. Neither one of these justified where they got the number. Neither one of them said, well, this is how we figured that out. But then I found a nonprofit in the UK who said the number was 700. Well, that's getting closer, but it's still half again as big as mine. And these people were a big organization. They had a list of PhDs this long on their website. So they must know what they're talking about. They said it was 700. But that's still way higher than I said. So what did I do wrong? I'm not a scientist, so I must have made a mistake someplace. And then I was very lucky. I came across this organization. These people supported what I concluded, what I calculated. They supported it. But the interesting part is they did it by doing science. They actually went out, found some carbon, found some rocks. It was 50 million years old, and then they split them up and they kept looking for fossils, and they found fossils. I believe this was north of the Arctic Circle. I could be wrong, but I think it was. They found fossils of leaves that were this big. And here's the interesting thing they did. Those fossils were so detailed, they could count the stomata in these big leaves. I didn't know what a stomata was, so I had to look it up. So forgive me if you know what it is, but I'll explain it because I didn't know. It's the stomata are those little holes in the leaves that allow the gas exchange, CO2 and oxygen. And these folks came to a very logical conclusion. They said, hey, if there's a lot of stomata, then that must mean there's just a little bit of CO2 in the atmosphere, and they need a lot of openings in order to collect enough carbon to, and the chlorophyll and the water and the oxygen to create the sugars which cause life. They need a lot of openings because there's only a few CO2. But if there's a lot of CO2 in the atmosphere, then they don't need a lot of openings. They only need a few. So I don't know how many how many fossils they counted, but they were comfortable. They're a university in France. They were comfortable, and they came up with a ratio. Now, a ratio makes sense to me, because this was 50 million years ago and we're looking at fossils. And I believe this ratio is correct. And in their abstract to their paper, they said right up in the beginning, the estimate we have come up with is much lower than what other people think it is. Well, duh, that's exactly the problem I'm having. And the second reason I believe this range is accurate, because the mid-range, the most likely number within that range would be the one in the middle, and that's 400, which gives us a temperature of 79.7, and that's awfully close to my calculation, 392. Theirs is an approximation, an estimation, a range. It's the best I could find, but it's still just a range. But I know there had to be 392 parts per million if you want the Earth to be 77 degrees. So let's do the arithmetic and see how hot the Earth is going to get. Total carbon put back in the atmosphere by humans, 415 parts per million. We know that because they measure it at Mauna Loa. That's very accurate. And we know there was 285 pre-industrial. So therefore, we know that in 2019, we had put back 130 ppm. For the record, in 2024, I think that 415 is now up to 426. But that's all right. This is bad enough. You don't need to worry about anything more than 415. So now, what did nature remove? Well, we know there was 392 pre-industrial. We know there's 392 50 million years ago. And we know there's 285 pre-industrial. So nature put back 107 in 50 million years. So now let's do the arithmetic. We divide 130 by 107, removed, and we find out that the carbon ratio in 2019 was 121%, 1.21. Multiply the carbon ratio times the temperature differential. Why? Because we want to know how hot the Earth is going to get. We put back a certain percent of the carbon. So we do the arithmetic, 77 degrees Fahrenheit 50 million years ago, 56 degrees Fahrenheit pre-industrial. That means that the nature cooled off the Earth an astonishing 21. I said that backwards. take that back. Carbon ratio is 121. The temperature differential is 21 degrees. That means we have put back enough carbon to increase the Earth's temperature eventually to 25.8. Now, if we add that 25.8 onto our 56, that means as of 2019, human activity had already put back enough carbon in the atmosphere as measured at Mauna Loa, 13,700 feet, so that the Earth's ambient temperature would be 81.8 degrees. That is a startling and deeply disturbing number. I don't see how you can argue with that approach. I don't understand for 1 minute why the scientists don't think this way, but if you saw this episode a few episodes ago, I talked to a lot of scientists and they just don't think of it. Scientists don't think of climate change the way I'm thinking about it. They think about it like scientists. They break the system down to the molecular level and they pick it all apart and they look at all the details. And I'm glad they do it, but that doesn't tell us what the problem is. When they explain climate change or global warming to Congress and to the world in 1988, they used a scientific approach which made it impossible for the average person to understand. Well, I am the average person, and I'm presenting it in a much clearer and irrefutable manner. There's way more carbon in the Earth than humans can stand. That's because scientists say, whether they're right or wrong, I don't know, but scientists say 64 degrees is the maximum, exactly how they said it was, at 64 degrees, the human species will have trouble surviving on Earth. That's what they say, and that's about as exact as you could get. Our civilization will be long gone, will have crumbled long before we get to 64. But 64 is impossible for us to live. And we have enough carbon in the air to go to 81.8. So I have to ask you, why are we fooling ourselves? Why do we listen to Madison Avenue? Why do we listen to what the government says or to what the industry says or anybody? There's enough carbon in the atmosphere to wipe out the human race many times over. We need to come to grips with that. It's a fact. You can't refute it. So what are we going to do? Well, that's the end of episode 3. And now you know how serious the problem is. In episode 4, I will explain that there's enough carbon in the atmosphere to make the Earth 81.8, if there's enough carbon in the atmosphere to make it that. Why is the Earth's temperature only 59.1? Thank you. See you in the next episode.